Good day everyone, and welcome to our first module in the course Oil and Gas Production Technology. This module will take us on a journey from the very origins of oil and gas deep within the earth, through the processes we use to find and extract them, and finally to the moment they first emerge from the well. We'll start with the big picture, what the oil and gas industry is, why it exists, and how it fits into the global economy. We'll then explore the science behind the formation of hydrocarbons, how we locate them, and how we drill wells to access them. From there, we'll move into completion, testing, and the fundamental reservoir engineering principles that govern production. By the end of this module, you should be able to clearly explain how oil and gas are formed, describe the stages of exploration and production, understand the key components of drilling operations, and outline the pathway of hydrocarbons from the reservoir to the surface. 1. Introduction to the oil and gas industry. Let's start by considering just how central oil and gas are to modern civilization. From the fuel that powers our cars, trucks, ships, and airplanes, to the raw materials for plastics, chemicals, fertilizers, and even clothing, petroleum and natural gas underpin much of the modern economy. The oil and gas industry can be broadly divided into three sectors. Upstream, this is the exploration and production sector, which includes geological surveys, seismic studies, drilling, completion, and the extraction of oil and gas from underground reservoirs. Midstream, this covers the transportation and storage of hydrocarbons, such as pipelines, tankers, and terminals. Downstream, this is the refining and processing sector, where crude oil and raw natural gas are converted into usable products like gasoline, diesel, jet fuel, heating oil, and petrochemicals. Our focus in this course is firmly within the upstream segment, with some attention to the interface between upstream and midstream, since production technology often involves elements of both. The upstream industry is highly complex, involving geology, engineering, physics, chemistry, economics, and environmental science. And while the industry is global, each producing region has its own unique geological, technical, and regulatory challenges. 2. Formation of oil and gas, petroleum geology basics. Before we can produce hydrocarbons, we must understand where they come from and how they are trapped underground. Oil and gas are formed over millions of years from the remains of microscopic plants and animals that once lived in ancient seas and lakes. Here's the process in simplified form. Deposition of organic material. When these microorganisms died, they sank to the seabed or lake floor, mixing with sediments such as clay and silt. Burial and transformation. Over millions of years, layers of sediment built up, burying the organic-rich material deeper and deeper. As pressure and temperature increased, the organic material was transformed into hydrocarbons through a process called thermal maturation. Migration. The hydrocarbons, being lighter than water, migrated upward through porous rocks until they were trapped beneath impermeable layers known as cap rocks. Accumulation. These traps form reservoirs, underground formations containing oil, gas, or both, stored in the tiny spaces between grains of rock. Reservoir rock types vary. Sandstones and limestones are common because they can store significant amounts of hydrocarbons and allow them to flow. The presence of both a good source rock and a trapping mechanism is essential for an economically viable reservoir. 3. Exploration and appraisal activities. Finding oil and gas is both a science and an art. Companies invest heavily in exploration to reduce the risk of drilling dry holes. The main exploration techniques include geological surveys, studying surface rock formations and structures to predict subsurface geology. Geophysical methods, most importantly, seismic surveys. Seismic crews use controlled energy sources, onshore often a thumper truck, offshore typically air guns, to send sound waves into the earth. Sensors record the echoes, which are processed into images of subsurface structures. Geochemical surveys, sampling soil and water to detect traces of hydrocarbons. Once a promising structure is identified, the next step is appraisal, drilling an initial exploration well, known as a wildcat, to confirm the presence of hydrocarbons. If the well finds oil or gas, further appraisal wells may be drilled to determine the size, shape, and quality of the reservoir. Exploration is high risk, high reward. Many prospects do not result in commercial discoveries, but a single large find can justify years of investment. 4. Drilling technology and rig operations. When a site is selected for drilling, specialized rigs are brought in to create the wellbore. Drilling technology has evolved dramatically in recent decades, increasing efficiency, reducing costs, and improving safety. There are two main categories of drilling rigs: land rigs, stationary or mobile rigs used for onshore wells; offshore rigs, including jackup rigs, semi-submersible rigs, drill ships, and fixed platforms. The drilling process involves spudding the well, starting the initial hole, casing and cementing, installing steel pipe, casing, and cement to stabilize the wellbore and isolate different geological layers. Drilling in stages. Drilling is typically done in sections, each with progressively smaller diameter bits. Mud circulation. Drilling fluid, or mud, is circulated to cool the bit, carry cuttings to the surface, and maintain wellbore pressure. Advances like directional and horizontal drilling allow wells to reach multiple reservoir zones from a single surface location, reducing environmental impact and maximizing production. 5. Well completion and testing. Drilling a well is only part of the process. Once the target reservoir is reached, the well must be completed so that oil or gas can flow efficiently to the surface. Completion involves installing production tubing inside the casing, perforating the casing at the reservoir depth to allow hydrocarbons to enter the wellbore, sometimes stimulating the reservoir with hydraulic fracturing or acidizing to increase permeability. Well testing follows, during which the well is flowed under controlled conditions to measure pressure, flow rates, and fluid composition. This data is critical for reservoir engineers to model future production and decide on field development plans. 6. Reservoir engineering concepts. Reservoir engineering is the science of understanding how fluids, oil, gas, and water are distributed in the reservoir and how they will move when production starts. Some key concepts include porosity, the percentage of the rock's volume that can store fluids; permeability, the ability of the rock to transmit fluids; reservoir pressure, natural pressure in the reservoir helps drive hydrocarbons to the surface; drive mechanisms, different reservoirs are produced by different natural drive forces, such as water drive, gas cap expansion, or depletion drive. Reservoir engineers use models to forecast how a field will perform over its life and to design strategies for maximizing recovery. 7. Flow of fluids from reservoir to surface. Finally, we need to understand how hydrocarbons travel from deep underground to the wellhead. Once a well is completed, reservoir pressure pushes fluids through the perforations, up the production tubing, and to the surface. Over time, as reservoir pressure drops, artificial lift methods like pumps or gas lift may be required to maintain flow. At the surface, the wellhead controls flow and ensures safe operation. From there, the production moves into separation facilities, which we'll discuss in detail in Module 2. Closing remarks for Module 1. In this module, we've taken a complete journey from the origin of oil and gas in ancient seas to the moment hydrocarbons first reached the surface. You've learned about the structure of the industry, the geology of petroleum formation, exploration techniques, drilling operations, well completion, basic reservoir engineering, and the mechanics of fluid flow. This sets the stage for our second module, where we move from subsurface science to surface operations, the facilities, processes, and technologies that turn raw hydrocarbons into marketable products, along with the challenges of maintaining safe, efficient, and environmentally responsible production.